Hello, this is Machine Learning Foundations for Product Managers Final Project Submission for Sean Ryman. To start with the modeling approach, I select supervised learning regression model. Basically, the problem statement was that I wanted to predict a target variable, which aligned with using regression as the approach here. I started by looking at correlation data for each of the features that were available in the data set. I did notice that AT and V had strong correlations to PE, while AP and RH were pretty weak. I interpreted this information as guidance to focus on AT and V from a modeling perspective versus the other ones. However, I didn't use that to restrict anything in the final model. You can see the correlations that I presented here along with the scatter plots. From a model building perspective, I used Excel as the tool with the analysis tool pack for regression, which is the tool that I'm most familiar with. I segmented the data using 70, 10, and 20 as my training, validation, and test percentages. I did this versus using K-folds. Just from a time perspective, had I used more automated tools, I might have used K-folds as well. I broke the model into 7 different pieces, one using all of the features, and then I specifically ran models for AT and V as a combination, AT and V while adding AP, and then AP and RH, and then VAP and RH. And I did this to really see how the model did from a performance perspective, both in training and validation, by limiting the sets of features and comparing them to the all variables or all features model, which had all of the different features added to that model. I did notice, similar to the correlation data, that AT and V, especially AT, were the highest contributors. You can see that here with the R squared values, the MAPE, and the other metrics in these analysis. But clearly, the all variables model was the strongest. From a model evaluation perspective, like I said, MAPE was the lowest here, which is what I decided to focus on. It's the metric that I'm most familiar with using to do these model evaluations. I also looked at R squared. Really, when you look at these other variables didn't add a lot of value. AT was the main driver of the model here. The results were pretty consistent when I looked at the validation sets to the training data. You don't see a lot of drift in these, except for some of these other models where there was only a few features included. I did notice that there were some outliers. You can see that here in the MSEs, in the training data, that it wasn't necessarily in the validation data, which is why there's such discrepancies between these two values. In the end, the clear winner was the analysis, like I said, with all the features. I really think from a interpretation perspective here is that if getting this data is all free, then I would certainly use all the variables here because having them all included, all the features included, created the best model. However, if there was cost to getting some of the other data, I may reconsider that and just focus on AT because that was really the single biggest driver of model improvement. From a model interpretation perspective, this was the final model. This is a scatter plot. You can see a really kind of tight distribution of predictions. The MAPE here was zero point 0.8. This is in the final test data set. You can see that 0.8 compares to the 0.82 from the validation and the 0.8 from the training. Not a lot of drift here from a final model perspective in the testing data set versus the other training data sets. So it felt pretty good with the fact that I use that as the model for final prediction.